All right, guys, in our morning class, we finished basics of electronics. For the next 1 hour or hour and a half, I'm going to focus completely on motor control. This is a make or a break for your exam. I'm hoping each one of you did the homework, which I was very clear on. Make sure you do the homework before you come here. And the homework is reading motor control notes inside out. Okay? So I'm hoping each one of you did this with doing those 50 questions on motor control as well. Now we're going to do some highlighting such that we know what's in the in this module that we need to study. First thing first, how does a basic motor control circuit works? Let's go to start creating some notes. So let's say you are driving, you bring your car on the driveway. What happens? The light goes on. Okay, it stays on for 5, 10, 20, 30 seconds until you park your car, you go to your house, and the light goes off. Okay, the motion sensor is sensing that the car came to the driveway, and the relays do the magic with on and off. Okay, so in a relay, it's combination of two parts, a coil and a contact. So let's call it relay A. Okay, the coil of the relay is the sensing part, that's called the sensor, and this is like an on-off switch. Okay, the relays are always represented, the coils are represented by this symbol, and the contacts are represented by this symbol on the schematic, okay, or a line diagram. But actually on your schematics that I'm teaching you, your relay is represented by, the coil is represented by the circle. So if I were you, I would rather switch it to maybe this symbol rather than this symbol. So let's just so you are not, guys are not confused. Okay, this is the symbol of the coil, that's the symbol of the contact. This guy is called the contact, the bottom one, the top is called the coil. Coil is represented by circle A. The contact will be either normally open, which is represented by this symbol, or a normally closed, which is represented by a line in the middle. Okay, so what happens when the sensor sensed motion? Car came in. Okay, the sensor sensed motion. What happened? The contact went from on stage to, or open stage to closed stage, and what happens? The light goes on. But there is a delay switch. Maybe there is 60 seconds delay or 3 minutes delay that has been created. 3 minutes later, once you are already in the house, the light goes off. Same thing for the fridge. In your fridge, you have kept the temperature for, let's say, 0 degrees for your freezer. The moment it becomes 1 degree, the fridge goes on. The moment it becomes -1 degree, it turns off. So is thermostat. Everything is controlled not by a person but automatically, which is the magic done by relays. That's the job of a relay. How is relay used as a device to control a motor is what I'm going to teach you. Okay, so easiest example would be, and you and I are going to do this together. Let's say you have a motor, okay, supplied by a 600 volt source. This panel is 600 volt, 600 amps, 3-phase supply. Okay, you install a motor right here. Okay, it's 100 HP, 575 volt, 3-phase skim, squirrel cage induction motor. Okay, now I need each one of you to go to table 44 and tell me what is my FLA. The rule we are trying to reanalyze is 28106, which is for single motor. So 99 amps. FLA. Thank you. Once you got an FLA of 99 amps, guys, stay with me and tell me what will be my conductor size. For a continuous motor, conductor size will be roughly 125% of the 99 amps. So for lack of better word, I'm gonna say roughly about 125 amps. Okay, let's not do any exact math. What will be my breaker size? My breaker size comes from table 29, which is 250% of the FLA, which will be roughly 250 amps. Are you with me? Okay. If you did not have a motor starter, this will be the reality for that application. Okay. So the moment you turn the motor on, it's gonna suck up how many amps? 600 amps. Remember we talked about inrush? Inrush is 6 times FLA. If a inrush for the first 20 seconds is 600 amps, how the hell your motor is gonna cross the 250 amp breaker and turn on? It's gonna keep tripping. Okay? To save the motor from burning, we need to put something called a starter, which is called a motor starter. So redrawing the same diagram with a motor starter is what I'm going to do on the bottom part of the page. So we still have the three-phase supply, 600 amps, 600 volts, three-phase input. And you still have the same motor, which is 100 HP, 575 volt, three-phase squirrel cage induction motor. But between these two items, I'm going to put a Y delta starter. What this is doing is taking the input as a Y from the source, converting into a delta, and giving it to the motor. Now stay with me for the numbers, okay? If you have 600 volts coming in here between line 1 and line 2, what is my phase? 347. We learned this last Saturday, right? So when the transformer between these two items is 1:1 ratio, my motor is now starting to work on 347, not 600. If my motor is giving a voltage which is almost 1/√3 times of the supply voltage it needed, the normal current rating of my FLA will not be 100 amps, it will be 1/√3 of the same value. What does inrush do? Inrush exactly acts like motor. Remember on the first day of our class, I taught to you about, oh, if your voltage goes down by a factor of half, your current goes down by a factor of half, and your power will go down by 1/4, right? Rather than a 240 volt baseboard heater, I'm connecting 120. A 10 kilowatt baseboard heater will now generate 2.5 kilowatt. Why? Because voltage is halving, current is halving, power will become 1/4. We talked about that on the first day. Same thing here. Inrush will do exactly what power does in a linear circuit, which is 1/√3 square. So inrush will go down like power by a factor of 1/3. So rather than a 600 amp inrush, we will have roughly about a 200 amp inrush, which will let the motor go through the starting phase. The starting phase usually is up to 75% of the rated speed of the motor. So if the rated speed of the motor, which I taught you last Saturday, is 1800 RPM, at 75% of 1800 RPM is the starter is kicked out and motor will be directly connected to the source. So starter come in for the first 10, 20, 30 seconds until motor is getting to 75% of its full load speed. So rather than starting with a jerk of 600 volts, it's slowly starting with 347. So when it's slowly starting, it's only sucking up 200 amps of inrush. The motor starts, slowly gets to maybe, what is 75% of 1800 RPM, let's say 1200 RPM. Once it gets to 1200 RPM, the starter has gone through, or the motor has gone through the inrush phase already. Okay, so this starter, which is designed in front of you, is kicked out and motor and the source are directly connected. So the dynamics or the schematic or the control that brings the starter in and kicks the starter out is the essence of the motor control stuff that I'm going to teach you today. What's the reason why we have motor control stations is because of lots of inrush that they cannot handle by just giving the supply voltage. Motors are not like light bulbs. They have to take their time to get to the full speed, and that's the process of inrush which needs to be rectified. And how do you rectify the inrush process is by doing low voltage starting. So you don't start at the same voltage rating as given on the nameplate of the motor. You always start motor at a lower voltage, which is called the low voltage starting. One method of low voltage starting is a Y delta starter. You could even use reduced voltage starting by adding some resistors to it as well. More resistance, less current means less inrush. That's another way of doing it. But most popular one for three phase is the Y delta starters. Cool. So now we go back and understand our module that I gave you guys to do it for homework. So let's get there. First thing first, you're gonna highlight that if I have right here, a single phase motor, this is my line, this is my neutral. I put one relay, which is a combination of a coil, which is represented by two C's put together back to back, and two lines, which is a contact. What are these two C's? Just like any overload device, what's the job of the overload? In the event of overload, get rid of the power. That's the whole beauty of having all these breakers on the panels. What do? In our kitchen, if we turn the, let's say if we turn the stove on, not the stove, let's talk about the microwave and the toaster oven on, what happens? On the same plug, after 5, 10, 20 seconds, it trips the breaker, right? That's called overload device. Why? The plug is designed for 20 amps. If you're sucking up 30 amps, the wire gets heated up. The wire attached to the breaker. Now the breaker is getting heated up. And breaker, what does it do? It has a bimetallic strip. It expands in the event of heat. Same concept here. Those are called OLRs right there. So in the event of heat, we don't call it on-off. We call it energizing and de-energizing of the relay. Okay? The relays get de-energized, and now the contact will open, motor will shut down. That's how any motor overload device work. Where are overloads mentioned in your book? 28306, I need you to go there, please. On 28306, it clearly says if the service factor is 1.15 or 1.1 or more, my multiplier is 125%, otherwise my multiplier is 115%. Okay, he's talking about these overloads that we are talking about. Where are overcurrents? Overcurrents are not on the motor, they are on the supply side. So just be aware, in a motor we have both overloads as well as overcurrents. Overcurrents are on 28200, overloads are on 28306. Depending on what was asked in the exam. What we are really focusing on is overloads, which is 28306 at the moment. So stay with me on the screen. If I have a single phase motor, where are my overloads located? Always on the phase, never on the neutral, right? So on the phase, I will throw a relay which will act as an overload device. A dotted line means a relay shown as a combination of a coil and a contact. If I have two inputs going in, do you see? One relay, second relay, a motor control. So two phases, two overloads. If you have three phases, how many overloads will you have? 3 overloads. Means 3 relays. Each phase will have one relay. We keep going. Chapter 2 talks about the features of how the basic magnetic motor starter does the job. Of course, it controls the speed right here, and it acts as a reduced starting voltage way, exactly what I just explained to you. But it also makes sure that the operator is safe. Along with it, it even controls the sequence. You know how sometimes in the mills, they will decide when one motor shuts down or one motor completes one assembly line, then the second motor starts and the third motor starts. That's called sequence control. Okay? So, in this chapter, the only thing you need to know is how a basic motor control circuit looks like, or a motor circuit looks like. So stay with me on this schematic. You have 3 lines going in, line 1, line 2, line 3. You have 3 contacts which are open. Until they close, the motor is not starting. You have 3 OLRs connected to 3 terminals of a 3-phase motor. Okay? The goal of that motor control station is to close these contacts so that motor can start. Okay? Now, important thing to know here is, how do you select the heater element? You follow 28306 to find the size of the heater element, which is what we talked about, the overload device size. Highlight this for me. We keep going. Chapter 3 actually tells you how to control the overloads devices. Okay? So, the first type of control that he talks about here is, before the control, he's only talking about the power circuit. Okay? You have 3 fuses, 3 M contacts, 3 OLRs connected to 3-phase motor. Why do you have the main disconnect? The main disconnect is connected to the 3 inputs, which is typical anyways. 3 fuses are providing overcurrent protection. The M contact and the OLR, the M contacts are open. Until and unless M contacts close, the motor is not starting. So these guys here are overcurrents. These guys here are overloads. Overcurrents are always on the supply. Overloads are always on the load. Okay? So, what are the different controls that he talks about? Number 1 is a 2-wire control circuit. How does a basic 2-wire control circuit look like? Nothing like similar to an on-off switch. You push the button, what happens? The light goes on, right? Same thing. You push this button, M coil energizes. When M coil energizes, M contacts will close, motor will shut down, or motor will start. Okay? In the event of power failure from BC Hydro. Okay? Let's say it's Friday, 4 o'clock, BC Hydro cuts off the power, and you were using this configuration or this kind of control for cutting some wood. Okay? BC Hydro cuts off the power, you go home, Monday morning you come in, the moment you touch your saw, your hand is gone. Why? Because the power comes in, the equipment turns on. Like a light switch. The moment power comes in, the lights go on. So this kind of control does not give any operator any kind of safety. You cannot use it for an application of a cut saw. Where is this story mentioned? Right here. So, if there is a power failure where the switch is still on, the motor automatically restarts when the power returns. This kind of control is called low voltage release. So he'll give you a schematic and say, tell me whether it's providing low voltage release or low voltage protection. That's your question number 2 in the exam. So how is it providing overload protection? The moment, let's say this circuit is designed for a 10 HP motor and you ended up putting a 50 HP motor here. The moment you put 50 HP motor, the heater elements are gonna get de-energized. The moment heater elements de-energizes, these contacts, which are your OL contacts, will open. Right? These OL contacts are in harmony with the OLR coils. When they de-energize, the contacts will open, current cannot go forward anymore. When the current cannot go forward anymore, M coil will de-energize. When M coil de-energizes, M contacts will come to an open stage, motor will shut down. So it's doing its job right as an overload protection device, but it cannot provide operator safety. Okay? So that's why sometimes we need a 3-wire control system if we need operator safety, like the way I gave you an example of a cut saw. What is a 3-wire control system? You have line 1, line 2, and the middle part, which is called a sealant contact. Okay? What happens here? Power comes in, you push the start button and hold the start button. The moment you hold the start button, M coil energizes, M contact, which is a sealant contact, closes. So you can release your hand, but the current has a path to flow through the sealant contact, and that is what turns the motor on, because if M coil is energizing, M contacts in the power circuit is closed. When they are closed, motor is running. In the event of overload, right here, let's say same story that I taught you before. If OLRs are getting heated up because you used a higher HP rated motor, the OLR contacts, which are right here, now will open up. When they open up, M coil cannot energize anymore or cannot complete the circuit, which means the M contacts now will come to an open stage, motor will shut down. Right? But how does it give operator safety? So, same example, Friday afternoon at 4 o'clock, the power from BC Hydro cuts off. What happens? The moment power cuts off, the sealant contact can only hold on to the charge for a few milliseconds and discharge. Once it's discharged and you come back Monday morning, you have to still push the start button, hold the start button for 2, 3, 5 seconds to make sure sealant contact is closed. So this dynamics right here gives you operator safety. That's why it's called under voltage protection, this kind of control. So highlight the last bullet point. We keep going. Figure 4. Okay, in figure 4, you have your pilot light on, which is the red light indicator. Question in the exam is, when do you think the red light will be turning on? The red light indicator will turn the moment M coil energizes, right? So the circuit, the way it works is M coil energizes, M contact closes, red light indicator will turn on. Okay, keep going. How is figure 5 different than figure 3?
Oh, we have multiple locations that you can start your motor from?
Excellent. You have multiple stops and multiple starts. So multiple stops should always be in series with each other. So you could stop this circuit from at in any location, but multiple starts should always be in parallel to each other. Okay. Exam question number 4. I am installing 2 stops. Should I be putting them in series with each other, parallel to each other, series with the line button, parallel to the line button? Series with each other. Starts are always in parallel to each other. How about a start and a stop? Are they in series or they are in parallel? A start and a stop, always in series. Exactly like this. Right? You see it.
Your stops were in parallel, they wouldn't work.
True, they won't work. Keep going. Now, diagram number 6, how is it different than diagram number 3?
Float switch and the selector switch.
So there is a handoff auto selector switch. We can put it in the manual location by going to pin 2. At pin 1, it's shut down. At pin 4, it's working on an automatic switch, which is a float switch. How is diagram?
A remote or?
It's literally a selector switch. Item 1, item 2, like a manual switch. You go to point 1, you are doing manual operation. If you're going to point 4, you're doing automatic operation. Question number, or figure 7. How is figure 7 different than figure 3, guys? Any idea? Who is the rock?
This is a full voltage control circuit.
There is more to it. Do you guys see this note? The OLR can be anywhere. So far, all the schematics I taught you, OLRs are always after the M coil. What he's saying is the job of an OLR is to open in the event of heat. They can be anywhere on this path. That is question number 5 in the exam. OLR should be in series with the line, parallel to the line, series with the start button, parallel with the start button. It's in series with the line. It can be anywhere on this path. The job of an OLR is to open up the moment overload happens. Okay, keep going. Next story, which is diagram number 8. How is diagram 8 different than diagram 3? Excellent, we have a step-down transformer. So we are designing the control schematic on 120 volt rather than 600 volt. Are we good? Okay, some of you. Okay, so keep going. In figure 9, it talks about all the schematic symbols of the switches. Guys, this is very, very important. Memorize the symbols very clearly. Okay, I need you to pick up a highlighter and highlight the symbol of a limit switch. Then highlight the symbol of a foot switch, motion switch. Right in the middle is a motion switch, pressure switch, level switch, temperature switch, and flow switch. Flip, next page. I'll get you to give you a printed copy. So, question in the exam. I am installing a liquid level switch to find out the level of the liquid for a reservoir. Okay, what is the symbol of the switch? Out of the 4 switches, which switch should I use if I want to use a level switch? Goran, he needs one more of this. Can you show her? Thank you. All right, we keep going. Next story we are learning is timed contacts. Okay, so make notes, guys. Either the contact is NOTC or NCTO. So NOTC, normally open time closing contact, or normally closed time open contact. How does it look like? It's a normally open contact like this, but with time it's gonna close. Or it's a normally open contact, so arrow is actually coming down, or arrow is going up. That's called NOTC. What is NCTO? It's a normally closed contact like this with arrow going up. It's a close contact with time it's gonna open, or it's a close contact that looks like this with time arrow is coming down. NCTO. I'll give you an example. At 9 a.m., or let's talk about regular work days, at 6 a.m. every morning you want your coffee maker to turn on. So you program at night, 9 p.m., saying I want the coffee maker to turn on at 6 a.m. Is it a normally open time closing contact or normally closed time open contact? So at 9 p.m. the contact is open. With time it's gonna close. So NOTC is the example of the coffee maker right here. We want in the campus the heat or air conditioning shut down by 4 o'clock every night. Is it NCTO or NOTC? Right now air conditioning is on. It's a closed switch.
And CTO.
Yeah. And at 4 p.m. it's gonna come on or open, which is an example of air conditioning in campus at,
Which is like similar to like your fridge. Your fridge would be like,
yeah,
I guess.
it's a close with time,
Normally
or
closed
other way
and
around too.
open.
It opens or
Yeah, it can be
closes.
either or.
It can be either or. But these are the timed contacts that you create a timer. Like I will go to the thermostat and create a delay of 8 hours, right? It starts at 8 a.m. and it finishes at 4 p.m. So the delay that you create is actually an NCTO. Cool. Next question. So lots of notes. So the exam question might give you a symbol and say which one is a timed contact. So guys, remember the timed contacts are the ones that has arrows going in and down or up. Okay. The other contacts that I showed you or other symbols I showed you are not timed contacts. Where are time contacts mentioned on this sheet? Right here. So energize, de-energize, write down NONC, NONC, just highlight all of them. We keep going. Next story we are learning is jogging circuit. What is a jogging circuit? So think of your condo building downtown where you have 500 people going inside the building from 7 a.m. to 8 a.m. because office starts sharp at 8 o'clock. So what's happening? The elevators are going up and down, up and down, up and down, taking 5 people, 10 people, 20 people between 8 a.m. and 7 a.m. Sharp 8 a.m. it calms down until lunchtime, which is 11. Right? So at 11 until 1, again people are coming in and out of the building to go get lunch. Calms down again until 4 p.m. to 5 p.m. when people are leaving to go home. Those are called jogging circuits. So they jog, they stop. They jog, they stop. During an application of a jogging circuit for an elevator, so let's say talk about elevator motor, okay? They close, open, close, contacts are closing, they're not getting time to cool down. And then somebody presses the button, they go to second floor, they go to 20th floor, second floor, 20th floor, second floor, 20th floor. That is called a jogging circuit. So when an application is of a jogging circuit, your contacts have a chance to get welded because they don't get much time to cool down. Think about a motor you turned on at 9 a.m. and you didn't shut down the machine until 5. Constantly running. There is no shutting, opening. There is no inrush happening. With this, there is so much inrush happening all the time. You close, you open, you close, you open for certain time, and then there is nothing. For jogging circuits, the contact rating that you're using is always 125% more than the rating of the motor. So if your motor is 100 HP rated, make sure your contacts are 125 HP rated, 125% more. Where is this story mentioned? Nowhere. Definitely in your exam. So just make a mental note for all the jogging circuits right here. Your contacts should always be rated more than the rating of the motor. How much would you jack up by 125%. All right, keep going. Now, the next story we are learning after the jogging circuit is what is the role of, how do you, your motor is running in the clockwise direction, how do you make it counterclockwise?
Reverse
Reverse the leads. So phase A can be switched with B. The cable B is switched with cable C. Exactly what's shown here, guys. If you switch or interchange any two leads, you will be able to convert the counterclockwise direction to clockwise direction. Okay. Now think of your garage door in your house. Okay. You have a garage door. When you push a button, the door goes up. When you push a button, it stops. When you push a button, it comes down. Right? Why do you think it's designed this way? Because you only have one motor. You have to tell the motor whether you want the motor to rotate clockwise or counterclockwise. Otherwise, you're confusing the motor. Right? That's called interlocking. So if you push the button and motor goes up, and you want the motor to, actually the door to go down, what happens? You push again, it stops. Push again, goes up, down, stop. So it's like up, stop, down, then again stop, up. So there is always a stop in the middle. You can't push and it keeps going up and up and up. Okay? Why? Because they are interlocked. If they are not interlocked, it can kill the dynamics of the motor or the whole mechanism of the motor, which will actually burn the motor. Okay?
So you end up shorting it.
Say that again.
You could possibly end up shorting it.
True. That's why this dotted line that you see on the schematic shows it's mechanically interlocked. There is literally a lock on the control part of the motor, so that at one time either the forward process is working or the reverse is working. You can't be pushing buttons to try to do the same thing. It's like a hand of a human being. Either we can push the hand up or down. You can't be doing up and down at the same time using one hand. It's the same thing for motor as well. Okay? This dotted line, I need you to highlight that and write down the word mechanical interlocking. The role or the meaning of interlocking is stopping the motor for getting confused. At one time, it will only do one process, either the forward process or the reverse process. Can be doing both. So stay with me on this screen. Let's understand how a basic garage door opener works or garage door motor works. I push the button, a forward button down. RB is a close contact, F coil will energize. When F coil energizes, FA will close, FB will open. And it'll keep doing its process until you push a button or stop, which is right here. Okay? Once it has gone to its full cycle of forward, what happens? You push the reverse button down, R coil energizes. When R coil energizes, RA will close, RB will open, reverse process will happen. But the part that's intelligent to see it is when reverse is happening, RB is open, so forward cannot happen. Same thing, when forward is happening, FB is open, reverse cannot happen. This is called electrical interlocking. Electrically, the schematic is designed in a way that even the mechanical lock breaks, electrically you cannot kill the motor. So the question in the exam is, the schematic in front of you, is it providing A, electrical interlocking, B, mechanical interlocking, C, both, D, none? What do you think? Both. There is mechanical through this dotted line. This is electrical that I just explained, so it has both. Keep going. Next schematic we are going to talk about is, most of the questions in the exam are big fat questions, but the answers are easy. Why? Because you don't focus on the diagram, focus on the question. If you focus on the questions are simple. But the diagrams, just by looking at it, scares people. Okay? So stay with me on the screen. I'm gonna throw a question at you. When I push the forward button, what would happen? 4 choices. Red light will turn on, amber light will turn on, green light will turn off, green light will turn on. None of the above, all of the above, which are not in your exam at all, which is a good thing. So what would happen when I push the forward button down?
Red light turn on.
Red light will turn on. What would happen when I push the reverse button down, guys?
The amber light.
Amber light will turn on. When would green light be turning on?
When it's stopped.
When I don't touch anything. So it's a power indicator. It's like laptop's power indicator. Because if I push any of the forward or reverses, either the F contact will open or R contact will open and green light will shut off and amber or red will turn on, depending on whether I'm doing the forward process or the reverse process. So what's the essence of a green light? It's nothing but a power indicator saying that the circuit is live. Cool? Keep going. Next story we are learning is more on, if I put my multimeter leads on this and that point, what will be the readings? So stay with me on the screen. Your supply voltage, your examiner is giving you, is 230 between all 3 lines. And he says if all the fuses are working out fine, he's given you the diagram showing every voltage will be 230, which is easy. What if one of the fuses are blown? Like here, fuse C is blown. What will be the reading on the other side of the multimeter? Nothing. Why? It's a hanging pin. It's not connected to ground. You're not defining the potential difference between line 1 and ground. It's a hanging pin. He didn't show a ground. So don't get confused. The output will be 0. Anytime any of the fuse is blown, do you see? It'll be 0. If all the fuses are working out fine between the line 1 of the first guy and the line 2 of the other side, still be 230. Because fuse is nothing but a piece of wire. If you have 230 between line 1 and line 2 on the top of the fuses, same thing between line 1 and line 2 on the bottom of the fuses will be still 230, right? Keep going. Question for you guys. What will be my voltmeter reading on this schematic? Guys? 230. That is easy. What will be my voltmeter reading before the OL contact? Still 230 because OL is a close contact. Keep going. What will be before the M coil? Coil is nothing but a piece of inductor. Still 230. Okay, keep staying with me. What will be the voltmeter reading across the start button which is not pushed down yet? Still 230. The moment you push it down, that's when you see 0 volts, right? Until then, the potential difference between L1 and L2 is 230, right? What will be the ohm meter reading across the start button, which is an open button? Infinite. So it'll show OL, OL, OL on your meter. Means it keeps on saying the word OL means overload, but technically what he's trying to tell you is it's an open circuit. When you push the start button down, your resistance will be 0. Right now, It's open circuit, resistance is infinite. Cool? Another question that comes in my head based on this, which meter do you not use in a live circuit? Voltmeter, ammeter, ohm meter, and megger.
Ohm meter.
Ohm meter. Ohm meter cannot be used on a live circuit. You have to shut down the circuit and then calculate the resistance by measuring or using an ohm meter. Very important for your exam. We keep going. This is my favorite chart. You're gonna get 2 questions, guys. So if you hate motor control, you better love this chart and learn this chart. Okay? The question will say, this is what my motor is doing. What do you think is the possible cause? If you are experienced in motor control, this will come easy. If you are not experienced in motor control, you better learn or memorize. Okay? What I had in my exam was, my motor is making a chattering noise. What do you think is the problem? I was given as one of the choices of low voltage. Okay? Or broken shading coil. One of my guys got a question on saying, well, my magnet of the motor is making a humming noise right here. Okay? What do you think is the issue? All it was given is just there is dirt on the magnet faces, clean the dirt and the problem will go away. Do you see? It's right here. So it says, what is the problem and how should I fix this? Just clean. That's the fixing. Right? As I said, motor control is a make or a break for your exam. Do not take it lightly. Buy your motor control book, which is right here. I've mentioned it as well. It's an excellent book to have. Honestly, I have no intentions of selling this author's book. I just love this guy's book because it's so tiny and easy to read and easy to understand. And I have mentioned it right here. Right here, Electrician's Guide to AC Motor Control in your binder. This is, when I did my exam 20 years ago, it was only $28. I've been told by my students like $60 on Amazon. If you don't want to spend $60, borrow it from the library, but you have to have this book. You have to read this book. It's excellent book to read. It's a skinny book. You could read 20 pages a day and then get this whole book done because it will clarify the concept of motor control. I honestly believe the 4 levels of schooling you do, motor control is not as detailed as it should be because you don't use it in the trade. But from an exam standpoint, these 10 questions are the make or a break. So you need to make sure your 10 questions are sorted. In my content that I've created at least 50 or 100 questions on motor control. But for you to do those questions, the concept has to be more clear, which because of lack of experience in motor control, you guys don't have that. So that blue book that your buddy is having, very good book to have. Okay? What I want you guys to do is do some questions with me. The module is done. So let's get to the practice questions. What page number is the practice questions on the motor control part, guys? 186? 177. Let's get there, guys. I'm going to choose the questions I want you to do. Ready? I don't want to do 50 questions in the class because I don't have the whole day. So we're going to do the questions that I think you want to do it with me. I'm hoping you guys did this at home as well. So this time you're not checking out the answers. You're trying to doing it yourself, okay? First question that I want you to do is number 2. After number 2, you're going to do question 7, question 8, question 20, question 26, question 32, question 33, question 34, question 42, question 44, 48, 49, and 50. Can someone count how many questions I've given you so we can estimate the time? How many? 13 questions, I'll give you guys 26 minutes. 2 minutes a question. We check our work at 11. It's 11:10 now, so 11:45 in maximum 30 minutes. Let's go. All right, let's review where we are at. Anything from question 1 to question 10 that you want me to answer? Question 11 to 15. Any troublemakers from 15 to 20? (21 to 30). (31 to 40). No troubles up to I do 48. I'm going to do 48, 49, and 50 on the board, all three of them, because those are the most complicated ones. Any troubles up to 47, please ask. All right, if that's the case, let's proceed. I'm going to do question 48 on the board. And this is a typical example of how the real questions look like in the exam. You have your source voltage is 230, okay? Fuse C is blown, and the question is what will be the voltmeter readings between these items, okay? So between 1 and 4, the voltage will be, guys, 230. Between 2 and 3, 230. 4 and 5, 230, no trouble. 5 and 6, 0. Why? Because 6 is a hanging pin and the C is broken. Okay? Between 3 and 5, 230. 2 and 5, 230. 1 and 6, 0. 1 and 2, it's a straight piece of wire between the fuse. So no potential difference between 1 and 2, which is still 0. And 3 and 6, because 6 is a hanging pin and C is broken, still 0. You get 2 questions on this concept, so you better pay attention. He'll give you a drawing and he'll ask you, tell me the multimeter reading. So just be aware of it, okay? We keep going. Question 49. Stay with me on the screen. Let's do it together. I have a 240 volt input coming in. Break off, break on. So off is when it's not being pushed down, on when it's pushed down. Right now, it's not being pushed down. BR is a brake relay, okay? You have 2 contacts, a close contact and an open contact. When BR energizes, these contacts will switch their state. At this point, nothing is being energized, okay? You have 4 diodes that converting AC to DC. You have a timing relay, which is controlling the R1 and the C. R1 is the resistor and C is the capacitor, and the time delay is product of R1 and C. If R1 was 100 ohm and C was 1 farad, the delay will be 100 times 1, which is 100 seconds. You're clear? Okay. Now, what is this thing all about? The whole schematic is designed to stop a machine. It's a stop mechanism for a motor. So think of a sawmill, okay? Sawmill needs to be serviced every 30 days, for example, but the delay has been created for 1 year. So if you don't service, the machines are gonna run 24/7. Cool? If you don't touch any of the brakes, power is coming to the diodes, AC is converted to DC, BR being a close contact, timing relay is energized, time delay is happening. So time delay could be 1 day, 2 day, 3 day, until 365 days. Okay. The moment you push it down, brake relay will turn on, BR contact will open, this BR contact will close, brake coil will energize, red light will turn on. So technically, you're pushing the brakes on the machine. Until that happens, there is an unlimited time delay. Could be 1 day, 1 hour, 1 year, 10 years, is controlled by this timing relay. So do you see how big this schematic is and how easy the question is? So what is the question? Question is what do you think the TR is providing, an on delay or off delay? So guys, TR is providing on delay or off delay?
Off.
After the delay, the equipment is turning off because it's running right now, right? If we push the brake, that's when the equipment shuts down. Otherwise, the equipment is running. Cool? What would happen when what is the job of R1?
Determines the time delay interval.
R1 controls the time delay. What's the job of R2? It's a current limiting resistor. Yeah. It will suck up what the brake coil doesn't need. It's in series with the brake coil, right? So if brake coil needs, let's say 24 volts and your source voltage is 30, R2 will suck up the remaining, minusing the source and the load resistor. So if your supply voltage, let's say, was 30 and brake coil needed only 24, 6 volts will suck up by R2. Those are called current limiting resistors. What would happen when I increase R1? Guys, time delay will go up. What would happen when I increase C? Time delay will go up. Right? Keep going. Last question, I want each one of you to draw this diagram on your notebook, please, which is the control part. All right, can I have your attention on the board? I need you to stop copying and just pay attention, because if you can understand this, nothing in motor control will bother you. Okay? So, the moment we push the start button down, just follow my red ink. Okay? What would happen? S coil will energize. The moment S coil energizes, SA will close, SB will open. If SA closes, 1M coil will energize. When 1M coil energizes, 1M contact will close. 1M and TR are in parallel. So TR coil will energize. If TR coil energizes, timing relay, which is a TR relay, so I would say time delay will happen. Okay? When time delay happens, what's item number 7? How do you have time delay? Do you guys see? There is something called normally closed time open contact right there. Okay? So after time delay, TR contact will open. As soon as the TR contact opens, S coil now will de-energize. The moment S coil de-energizes, SA will open and SB will closed. If SB closes, 1M was already closed, 2M will energize. So guys, what do you think is happening here? Between S and 2M, there is something called mechanical interlocking. Do you guys see that? Means when you are bringing the motor starter in, you cannot kick at the same time out. So the S coil, if you look at the schematic, here, do you see you have 3 coils? If you close the S, if they become normally closed contacts, they are a Y. If your 2M closes, they might become a delta. So Y is being converted into delta when S closes. Time delay is happening so that we go through the cycle of inrush. And after the time delay, the 2M coil is actually being energized, means now delta is being converted into Y. In a nutshell, you're kicking the motor control center out so that the motor is directly connected to the source. There is no starter in the middle anymore. So the whole thing that I explained it to you is nothing but a Y delta starting process controlled by the S coil and the 2M coil. That's happening. Okay, so stay with me. What type of motor starting circuit is being illustrated? A delta Y starter. Sorry, Y2 delta starter, right? We are reducing the voltage by √3 and inrush by 1/3. Question number 2. List the sequence of operations that would happen. We already did this on the board. Okay, I'm going to put this on the screen again. Is TR on delay or off delay? So after the delay, is motor going to full speed or shutting down?
Shutting down.
No, full speed. Because after your starter is kicked out, motor is working on 600 volt 3-phase input. Right? So the starter process is done. Motor is not working at 75% of its rated speed. It has arrived to rated speed. How would it arrive to rated speed? When you give full 600 volts in. Which means motor is now running at full speed. Now if 10 HP 460 is my rating on the winding or on the nameplate, what is my maximum voltage on the winding? 460. And what is my maximum current on the winding? 14 amps. Right? Because whatever is on the nameplate is the maximum ratings the windings can have. You can't have more than that. overload relay heaters shown in the above circuit should be selected on what value of current? Guys, this you are going to do this with me. So, OLRs right now, based on the nameplate rating, what's my line current? 14 amps. We're going to do this together so you are clear. You know that the overload devices are always on the phase, never on the line, right? So what is my line current? 14 amps. What will be my phase current? 14 divided by root 3, which is 8.08 amps. Now I want you to go to rule number 28306. Am I given the service factor on the nameplate?
That was 1.25.
Service factor is not marked. It's not given, right? On the nameplate, which means my overload device will be calculated by taking, am I given service factor or no? Not given, right? If the service factor is not given, what is my multiplier? Based on 28306. 115%. So I will take 115% of 8.08 amps, which is 9.3 amps, and you guys rock. Just make sure you understand, guys, overloads are always on the phase. Please do not make a mistake in the exam. Overloads are always on the phase, never on the line. So for you to calculate your overload device, you must know your phase current. Okay, the last question in the list that we wanted to do is, why do I need to mechanically interlocked? Yeah, otherwise they're going to burn the motor. Because when S is working, 2M cannot work. It's like garage door, right? I explained it to you. If they are bringing the starter in, you cannot kick the starter out at the same time. The motor has to bring them in, do its jingle for the first 10, 20, 30 seconds, and then kick them out. That's why they have to be mechanically interlocked. Are they electrically interlocked or not? Let's see who is my rock star in the class. I need you to look at the schematic that we just worked on and tell me whether the schematic provides mechanical interlocking as well as electrical interlocking. Yes. How?
Yes, it was electrical.
Very good, but how? So I'm going to pull that on the screen, my old diagram. So stay with me on it, guys. Do you see? And I'm going to use another color. I love this stuff because, it's very logical. Look, when S is working, this guy opens up, right? So 2M cannot work. And when 2M is energized, this guy opens. So S cannot be energized. Do you see? Electrical interlocking. So you're doing electrical as well as mechanical interlocking because it's on the diagram anyways that we're providing mechanical interlocking. Are we good? You're clear? Can we proceed? Okay. This finishes Wonderland of motor control. How do you guys feel about motor control? Better than the moment you walked in? Yeah, the concept is much better. Yeah, that I can assure you. You might not feel you're ready for the exam, but you definitely are better than when you walked in at 9 a.m. this morning. So, we are gonna do a little exam. So if I do the exam now, you would not get your lunch break until 1:30. So I'm gonna give you guys a quick synopsis on what's left that we are gonna do first. I'll give you guys your lunch break a little early such that when you come back, we are gonna do the test right away. Okay, it's a small test I've created. I'm hoping you guys bring your laptops because I asked you to bring your laptops. Yeah, I've reminded 4 times saying on the last day, please bring your laptops because we'll have a small exam. 4 times I reminded in the last 6 weeks, guys. So, none of you have laptops? Both of you? You have yours? You don't? How far do you live? Can you go get a laptop from your house? Where do you live? Vancouver. And for you, dear? Fort Moody. Oh. So after motor control, the only topic I want to point out is, if you go back to your binder, the first page, guys, do you see something called trade concepts? Trade concepts means trade knowledge. On trade knowledge, you get 11 questions in the exam. Where are those 11 questions mentioned? Right here. Block A has 11 questions. Okay? Let's review where we are at with the trade knowledge concept. So, get to page 195 of your binder. And the first question that I want to point out is on symbol of clock plugs and where do you put clock plugs. Open up your code book, look for the word clock plugs or clock outlets. Tell me what rule number are we going to. Or go to the back of the book, which is your index, right? And look for the word clock outlets or clock plugs. Right here. Do you see clock outlet?
You go on the fridge circuit, I know.
On the fridge circuit, but where does it say in section 26, guys?
Yeah, that's what I was saying. I'm trying to remember where that is.
It's definitely in section 26. Tell me the rule number.
Yeah.
Yeah, come on in.
Hi, how are you?
Good, how are you?
Good, thank you. Hi, I'm not going.
So, did you guys find the rule number for clock plugs?
Yeah, 26, 254.
26254? Excellent. What does it say? Same circuit as the fridge circuit, right?
Yeah.
Question number 1, 10 more to go. So, what is the symbol of a clock plug? Looks like this. And where do you put it? Same circuit as the fridge circuit. Are we clear? 654?
I don't think it's 254.
Okay, 654.
Yeah, I was saying 254 doesn't make sense.
All
That's the
right.
transformer.
As long as you guys saw the rule, highlighted it, put 3 asterisks on it, we are sorted. Okay, very important. Question number 2. What is this guy doing? Okay, 4 choices. Point forearm, index finger upward, make small circles, extend an arm, close fingers, close, whatever. Like, he'll come up with 4 names. You should know what these crane hand signals are doing. Okay? Okay, I'll get her to get you one. Next one after that, question number 3. If I'm working on the job site outside and it's minus 40 weather in winter and plus 30 weather in summer, let's talk about Saskatoon or Edmonton, what type of ladder should I use? And the 4 choices are wood ladder, PVC ladder, fiberglass ladder, and aluminum ladder. Any idea? Fiberglass ladders are the most popular for everywhere. Easy to move, but they are not PVC either. Okay? Question number 3. What angle the ladder should be at before I go up the ladder?
It's
4 to 1, which is 75 degrees. Okay? If I have a 10-foot ladder, how far should it be from the wall? 10 divided by 4, so 2.5 foot. The way you want to do this math is maximum and minimum. Okay, what could be the maximum distance? It's always 3 to 1. What will be the minimum distance? 4 to 1. So if you have a 10-foot ladder, okay, the maximum is 3.33 feet and the minimum is 2.5 feet. Anything in between is acceptable. Okay, if he doesn't ask for maximum minimum, always choose the 4 to 1 ratio. If he doesn't mention about give me the minimum, give me the maximum. Question number 5. I am standing right outside the house. Okay, my extension ladder is right here. What is the highest point of the house to the highest point of the ladder that I can go up to? Maximum allowed is 1 meter. From the top point of the roof to the top point of the ladder, which is what? 3 feet. Another question, number 6. I'm standing on this ladder. What is the highest rung I can go up to? Second from the top, first from the top, because the top doesn't exist, guys. This is like the top doesn't exist, which is called the first. Okay, this is actually first is actually the 0. This is called first from the top and this is called second from the top. So you can stand right here. Okay, what else? Lot of ladder questions. So where is the 3:1 and 4:1 mentioned? Right here. The story that I just taught you about the 3-point contact when you're going up the ladder, it's right here. So if I were you, I will read these notes carefully. Now I bought an equipment which has this symbol. Okay, what does this symbol mean? So most of the time people get confused with the symbol between or difference between flammable and oxidizing. So the way you want to memorize is capital O is oxidizing, small o is flammable. Okay, both are a fire symbol. What I had was dangerously reactive. This was for me. But question number 7. Question number 8, classes of fire extinguishers. If I am on a job site and there is a fire because of an oil spill, what class of fire extinguisher should I use? B. If there is a fire because of an electrical fault, what type of fire extinguisher should I use? Class C. If there is a fire in cooking appliance that involves combustible cooking media like vegetable oil, class K. You'll have to memorize all of these, guys. Keep going, and the whole classes are explained again on the next page very well. What type of hard hat would I use when I just don't want to spend money and I just need to have a hard hat? The conventional one, which is called the type 1. Which hard hat should I buy when I really want to make sure if I fall down and I have full support on my head? Type 2. Okay, I am an electrician working with BC Hydro. What should be the class of this hat that I should purchase? Class E. I am an electrician working with 750 volts. What class of hard hat should I buy? Class G. I am a student attending apprenticeship training at Ace Community College. What class of hard hat should I purchase? Class C. Okay, keep going. Understanding over voltages installation category. I am a student, okay, who is working with basic apprenticeship training. I have to go buy a multimeter for myself. Which multimeter should I buy? What category? Yeah, and it took me freaking forever in the exam to find this answer. Nowhere in the content was there when I wrote my exam, so I've added it here. Category 1 is for somebody who is working with the most cheapest meter. Okay, category 2 is more of an appliance service technician working with single phase systems. Category 3 is for you guys as an electricians working with single phase and 3-phase systems both. Category 4 is for the guys who are working with high voltage installations, typically for the utility. The more category you go up, the more accurate the meter is, the more expensive the meter is. This finishes our trade knowledge part. I have created for you guys 150 some questions as you see my screen. If you please do these questions for homework or right before you write your IP, you're sorted. These 11 questions are free 11 marks that you get in the exam. Okay? So, and you can see that I've made your life so easy by creating all these questions. It's 126 questions on trade knowledge. Okay? That requires minimum 4 to 5 hours to do it right. So just invest some time to do these questions at home. They're all trade knowledge questions. Some of you have been living in Canada for over 10-20 years, so your trade knowledge is sorted, but some of you came from another province or country. So, you know, the trade knowledge that we follow here might be different from back home, so always a good idea to do these questions. This literally finishes everything I wanted to teach you before we take the test. So, as I promised, I owe you guys I haven't even given you a proper coffee break. So I'm gonna do a coffee break and a lunch break together. Do you want 30 minutes or 45 minutes, guys? Let's do a 30-minute because we have to start the exam by 1. I don't wanna push it any further than 1 o'clock. So be back in 30 minutes. It's 12:24 now. You get 35 minutes to do a lunch. And as soon as you come back, please get your laptops ready and Moodle login done. So Moodle logins were emailed it to you when you signed up for your course a day before you showed up here. So please log in into Moodle, be ready to go. I'm gonna open the exam sharp at 1 o'clock. And we would do this exam. I think the exam is, if I'm not mistaken, 60 minutes long, 1 hour. We should be done by 2. So from 2 to 4, we can review the exam to ensure that you guys are all sorted before you go home. All right, have a good lunch.